Hello and welcome to my presentation. My name is Mwansa Lumpa. I'm a PhD student at the University of Bern with an affiliation at Swiss DBH. My supervisor is Dr. Julia Bolis, Dr. Samuel Bosompro, and Dr. Miguel Duran Frigola. So I'm going to present to you what we've been developing, an end-to-end record linkage to, which is supposed to be simplistic in nature for use by everybody. But the motivation behind this is the existence of two data sources. One for the cervical cancer program that was set up in 2006. The program was established to screen and treat HIV positive and negative client. Once a client was identified to have cervical cancer, they'll be referred to the tertiary hospital in Osaka called UTH. Over time, over 400,000 patients have been screened through this program. The second program is the antiretroviral treatment program, which CIDRZ has been running in the country since 2001. And this program supports the Ministry of Health in providing HIV prevention and treatment services. It's been around in four provinces, and over time, over 500,000 records of patients have been recorded, or they've received their service. The system that's been utilized for this is SmartCare, which is the National Electronic Health Record System, which collects longitudinal data on patients as they come to the clinic to receive services. Now, these two systems sort of are the foundation on which we want to do record linkage. Unfortunately, both systems do not have a common identifier across them, and this is in part due to the nature in which the two programs were run. Historically, there's been a bit of integration between the programs over time. And then secondly, the cervical cancer program over time has utilized two data sources, a SmartCare, a Microsoft Excel dataset, and a Microsoft Access dataset. The Microsoft Excel dataset captured only a snapshot of a patient's visa, whilst the Access database tried to collect comprehensive data on the patient. However, due to the workload on the clinician, the Excel database is more comprehensive, is much richer in terms of volume of patient records collected. On the other hand, SmartCare was utilized primarily as the primary system for HIV data collection. However, paper-based system is in existence, so potential for missing data is also. Now, as I mentioned, the lack of a unique identifier across the systems is really a challenge, and as such, record linkage in an automated manner could be challenging. And this challenge can be presented when you want to run estimates of how the coverage of patients, HIV patients who have received cervical cancer screening. In addition, the existence of very limited variables in the cervical cancer dataset to link with the SmartCare dataset is another challenge. However, approaches do exist for linking data across data systems that are lacking in a common identifier. Probabilistic methods and machine learning approaches have been used in studies to link heterogeneous data sources. However, these approaches, for the most part, have required individuals who are highly skilled to run them. They require a lot of manual work to complete them, and not only that, it takes a lot of time. They need a lot of computational resources to run efficiently, otherwise they'll take months to complete. So we opted to develop a framework for efficient record linkage, which we're calling an E2E link. The idea behind these two is that we want it to be simplistic. We want to have very few interactions with the person who's running to complete the linkage. However, I should stress that it still also allows for modifications or configurations that build on existing logic to add more custom logic depending on what the user of the system wants to achieve. The efficiency that we have from this system is born out of pre-trained models with large data sets, synthetic data. In addition, pre-training of the models could also be done by data that's been collected and reviewed, going through clerical reviews. Now, the implementation of our system has 6 parts to it. Of course, it starts by ingesting 2 data sources. One is a source and then one is a target file. So in the scenario that I presented, the source in this case would be cervical cancer dataset, and the target is the smart care dataset. So you go through the process of schema matching, pre-processing, blocking, comparisons of records, scoring of the matches after the comparisons, and eventually evaluating how good the linkage is, and eventually get your output files. Under schema matching, what we do is that we've predefined fields that when we load an Excel sheet, we're able to tell whether this field is a first name, last name, date of birth, age, and various things. And this is born out of this is out of the experience that we've gone running the data set that we've been running. Then the pre-processing stage is similar to what you see on the right side, where you get names or date of birth and then standardize them into a standard format before it runs into the blocking, comparison, and subsequent stages. And then each reference field has an associated logic, which is extensible. So if the existing logic for cleaning first name and last name or name is incomplete, it allows the end user to create more robust logic to it in a very simplistic manner. Yeah. Overall, this makes the pre-processing tool very extensible, and it can run independently of all the parts in the system, which is a use case for all the different stages for the program. Then we have the blocking stage. So the blocking stage, what we do is that when we have the source dataset and the target dataset, a single record in the source is matched across records in the target dataset. Now, because we cannot do a Cartesian product to match the 2 dataset, we block the records and we utilize a library called phase an ultra-fast search algorithm for fuzzy matching. I've added a link there if you like to learn more about it. And we pass the first name and last name and age to this blocking tool to come up with blocks of whichever number that we want. So we've tested with blocks of 30, we've tested with blocks of 20, and we've tested with blocks of 10 and 5. What we've realized is that when we even run with blocks of 5, we're able to achieve good results as if we ran with blocks of 10, 20, 30, and more larger blocks. So we reduce them just for efficiency purposes. Then after the blocking stage, remember I mentioned like you have one record from the source dataset which you match against another record in SmartCare. We utilize various similarity algorithms for the match. In this case, we utilize cosine, Levenstein, Jarrow-Winkler, and various other numerical and string matching algorithms. This eventually gives us a weighting of each of the comparisons that were done, which we now feed into the scoring module. And the scoring module, what we eventually do is generate a single probabilistic score. To do that, we use classifiers, various classifiers, the default being the random forest classifier. Yeah. The last stage is the evaluation to just make sure that the datasets, that the linked datasets are accurate and give confidence to the person who ran that indeed their outputs are accurate. That's the evaluation stage. This stage doesn't necessarily have to be run every time. Like I mentioned, all these modules can be run independently of the other. The output, as I mentioned earlier, that the whole point is to develop a really simplistic tool, and this simplistic tool is that when you click or use an upload file, all this is done for you. So this is what you eventually get, the 3 CSV file and 1 Excel file, which shows the merged records and how they were scored. We've tested this on a dataset for one clinic in Lusaka, where 20,181 HIV positive patients received HIV services, and of those, 32% of them underwent cervical cancer screening, of which 732 were VIR positive,
5249 were negative, and the rest had indeterminate results. So this work is my PhD work, and it's work in progress, but we are trying to build as much documentation around it that others can collaborate with us. In addition, we have it on GitHub where you could contribute in terms of code. We will eventually open source it, that we could get other collaborators, and collaborators could contribute towards the documentation, coding, and testing and evaluation of our tool. You can reach me on mshashu@gmail.com. And this is the end of my presentation. Thank you.